Okay, everyone, let's resume our session again.
Yes, sir.
All right. So we discussed about that we have a different area type, right? And now we have to discuss the spatial area design. Means, as I mentioned that we have to understand what is the role of the stub area, what is the role of the totally stub area, and what is the role of the NSSA area, and what is the role of the totally NSSA area. And after that, we'll do the LSA verification. So for time being, if I go and check before designing the special area and you want to see the LSAs. So as I mentioned that we have the different LSA 1, 2, 3, 4, 5, 6, not 6, we are not going to see that 7. So at least I can see which all LSA in our topology. Anyone can tell me by defining this topology, what LSA all I can see as of now? Can I see LSA 1? Yes or no?
Yes.
Okay. What about the LSA 2? Can I see or no?
Yes.
Yes.
LSA 3, can I see or no?
Yes. Yes.
LSA 4,
Yes.
LSA 5,
Yes.
okay. LSA 7,
No.
no. So we able to see these all LSA. Where is the LSA 1, 2, 3, 4, 5, right? And also LSA 7 will see as of now no available. So let me show you one by one all LSA so you guys can understand. So if I'm
Fantastic.
going on the, yeah, if I'm going on my AVR router, right? This is my R4 router is acting as a AVR router. And if I run the command show IP OSPF database, you will see in database this link ID, right? Means router link state. These are the all considered as a LSA1. See, these are the LSA1. Clear? Router link state. It's a LSA1. Net link state, that's a LSA2. Who generate? DR generate this LSA2. Right? And this is the summary LSA. You can see this is the routes we're getting from summary LSA. That is the your AVR is generating the summary LSA. This is the LSA 3. And this is the your summary ASBR LSA. Means this is going to be tell about the your this is going to be your LSA 4, right? Means who is router generating this LSA. So this is the summary ASBR link. So that is the LSA for ASBR LSA. And now you can see under the this is under the area 0. Area 0, you can find this LSA 1, 2, 3, 4, right? And if you go for the area 11, right, you can see here you getting the LSA 5 as well, type 5 LSA. So this is the LSA 5. And now you are in the AVR, that's why you're getting the two different LSA informations, right? LSA 5 in area 0, LSA 4 you are getting in the area, sorry, LSA 5 in the area 11, LSA 4 you are getting in the area 0. But if I'm going in the R1 router, means this iOS 1, and then check the database again, and then you'll probably find a difference database. You're going to get only single area. So every database is going to be only one area. This AVR have two area. So every area have the different type of the LSA, right? One area have one type of the LSA, another have the another type of the LSA. But if you go for the your R1, then in this R1, you just check show IP OSPF database. See, these all are in the area 0. So LSA 1, LSA 2, LSA 3, summary LSA is LSA 5, sorry, LSA 4 and LSA 5. See, these all are coming in the area 0, and this is a special LSA you're getting from the, and who's advertising? This is advertised router. So this is how you can get this all LSA informations and this LSA database. So LSA 7 is still not coming. So we'll see LSA 7, how it is going to come. Moving further, now we have to define the special area. Let's suppose I want to configure this area as a stub area. So how we can configure this as a stub area? So I simply go in the my OSPF configuration. And if I want to make that as a stub area, then I'll just go and make this area is going to be stub area. So why we are making the stub area? That is the important questions. Sakil, you know why we make this stub area? What is the reason to make this stub area?
Yes, sir. To block the external LSAs.
And why we are blocking the external LSA?
If sir,
we just don't want to
small
advertise the
organization, we
Give me 1 second. I'm coming back. Somebody is knocking door. Just 1 second. Meanwhile, you guys think it.
yes.
Yeah. What was that?
Yeah, to reduce the number of LSA 5, and we would just
Yeah. So
only use the default route. We would only use the default route for the external domains.
okay. So let me first explain. So if you're going to make
and
this
sir, what is the
yeah, go ahead, please. Hello? You lose that connections.
so
Binay,
sir, if the
your voice is breaking, Naveen.
if the remote location,
Your voice is breaking.
1 second, sir.
Yes, sir, you're saying something to me.
No, sorry. I think you were asking. Naveen is asking. Sorry. So to minimize means basically to minimize the flood of LSA. That's why we use that special area. So basically what we have to do that, let's suppose by default all LSA I'm getting this area, but I want to just receive the
No,
still not LSA1, LSA2 and LSA3. I don't want to get any external LSA, any ASBR LSA, right? Then I can make this as a stub area. Means I just want to get the LSA 1, 2, and 3 informations. Then I can make this as a stub area. If I want to make the LSA, means if you want to configure the totally stub area, in that case, this area only receive the LSA 1, LSA 2, no LSA 3. Okay. But the major question people confuse here, if there is no LSA 3, then how I can communicate to other areas? So technically you are going to get LSA 1, LSA 2, LSA 3. Means if you are going to make this area as a stub area, let's suppose you are going to make as a stub area. So this area is going to become your stub. Only it is going to allow to get LSA 1, 2, and 3. This 3 LSA is going to be there in this area. But you're going to make totally a stub area, right? You're saying I'm just going to allow LSA 1 and LSA 2. So the question is, if you make that totally stub area, does this area going to talk to any other area? What do you guys think? If there's no LSA 3, then how I can go and talk to other area? Now it is not going to come.
Route. Need the default route.
So we need one of the default route, right? So this default route come in which LSA? Because we allowing LSA 1 and LSA 2.
3.
So LSA 1 is a router LSA. LSA 2 is a network LSA that is generated by the DER only. But who generated the default route? So generated by the AVR. AVR, that means LSA 3 is going to be still there, but only contain default route. Okay. Only going to contain default routes. Default route. That is a LSA. So technically, if you're making the totally a stub area and stub area, this is totally a stub, this is the stub. In both cases, we are going to get LSA 1, LSA 2, and LSA 3. I can prove in the lab. Okay. In both cases, you are going to get this LSA configurations. But in the stub area, you are only going to get in the stub area, you're going to get LSA 1, LSA 2, and LSA 3, which have the full routing information about the other area. But if you're going to make the totally stub area, this will get LSA 2, LSA 1 as a full routing, but LSA 3 is going to be only carry your default route. Technically, we have the all 3 LSS. Clear to everyone? So let's do the configuration for the special area, that is a stub area. So I will go here, and how I can make the configuration, I'll simply go and I want to make the area as a stub. So this area I want to become a stub area. So I'll go here in the R4, okay, and configure to show run section OSPF, and and I'll just make as a area ID is 11. 11 I want to make the stub, so I'll just make as a stub. Okay, done. So you can see this is down, right? Force reset. I will go in other side also. This router also I'll make that as a area as a stub. So area type must be match. In hello packet, we send the area type. So right now you can see OSPF neighborship is down for this one. So I'll need to change from there as well. So do show run section OSPF, and you will see this is also going to be, see, this is the OSPF, and I can just make as a area 11 as a stub. Done. So area type is match. So you can see your neighborship is come up. So whenever going to be different area type, you are not going to be build the neighborship. So once I change my area, my immediately neighbor went down. So to make sure my neighbor is going to be come online again, I reconfigure my area, and then after my neighbor come offline. Okay, so now if I just validate the theory which I explained right away, this stub area should only going to carry LSA1, LSA2, and LSA3. This will never allow the external route. Still, I am doing the redistribution. You can see, still I am doing the redistribution. But if you just visit the R5 and check the configuration, if I'm doing the redistribution, OSPF, I'm just redistributing the EIGRP route. See? But does this going to be installed in the OSPF database? You can better check on this R4 point of view. So you can check show IP OSPF database, and I can give the router. I want to check for the area 11 only. Do you have any command? I'm not sure about that.
Yeah, router external.
No, router external not. I want to check the area by edge. The area is not there, right? Okay, leave it. I'll just press it here. And I'm not going to check for the area 0. I'm going to check for the area 11. Okay, so you can, in this area 11, you can see how many LSA you have now. Amrita, please mute yourself. Amrita, you can mute yourself, please. So you guys see here, we have that is my area 1, sorry, LSA 1, LSA 2, and LSA 3, which carrying the all your route. Means this is going to carry your all route. If you go for there as well, this one as well, show IP OSPF database, you can see only 3 LSA. There is no other LSA available. Only 3 LSA. You can check the show IP route. You getting the all route from your remote locations. All route from the remote location, you're getting that. But if you go for the R1, you're not going to get any advertised route coming from the EIGRP. External route is not coming, and that is not going to be come here as well. See, there is no even E2 route is available nowadays. So once you make the spatial area as a stub area or totally stub area, you will not get any kind of the external route. Is it clear? You can get only the area, means the LSA1, LSA2, and LSA3. But now if you make this area as a totally stub area, then what is going to be happen? Even this LSA3 route will minimize, and you will only get the default route. How it is going to be happen? Let me show you. So go here in the configuration, show run section OSPF. And if I go here configuration, router OSPF, and I will make as a stub. You have to use a no summary. No summary is basically totally stub area. If you use a keyword no summary, that is the totally stub area. The moment I will configure, you'll see you need to go here as well and show run section OSPF and configure this. Okay, so you can see this has become my again special area, and I'll just clear IP OSPF process, clear IP OSPF process. Okay, so you can see still you have the neighbors. Now, if you check again database, let me show here from show IP OSPF database. See, you are getting just one of the default route here. Link ID, this one you're getting that, and earlier we have in the full subnet. You can see this database having the full subnet, like everything was there. Default route was also there. Along with that, you have the specific route subnet as well. But now if you check show IP route, you'll get one of the default route only. There is no specific subnet coming from the your AIA route. Means AIA route is coming as a only default. But in previous output, you can see all your these routes are coming. So totally stub area is going to make only allow show IP route here. You can check that. It's also going to get so IP OSPF database will show that because it will go in the area 0. See here, only we have a default route generating from this particular router as well. Clear? So if you have the any kind of the area, a special area, totally stub area, you are only going to allow the LSA1 and LSA2, and this will only going to carry default route under the LSA3. That is a totally stub area.
So, sir, it will not show in the global routing table the default route. The default
route in R5, you can see. You see here in the global routing table, you're getting this that's generating from their which router? This router, right? And
yes.
If you go for the R4, let me check if we have any start default route or not. Show IP route 0.0.0.0. No route available. So this technically not needed, right? This router is area 0. This is the ABR, right? So ABR is already have all the routing information, so it will not generate default route by default by here, right? But the any other router which is the part of this area 11, these all are going to get the default route, right? And by default, you can see if I want to go on the ABR for any route, they will take a default route. They come to the ABR, and ABR have already all the route information. They will go to the backend side. So if I'm in the R5, let me show the live. If you're trying to ping 1.1.1, see you're able to ping. Why? ABR doesn't run a default route. This having the all specific route already available. Make sense, Akhil?
Yes, that's true.
Yeah, only those route is going to need it, which are basically going to part of the your different area in the stub area. So they will get the default route. So they will come to the ABR, and ABR have all the routes, so they will come to the your destination. So this is how it is going to happen.
Yes, that's true.
Yeah. Okay. Now let's suppose we have to inject the external route. So Stub having a problem, Stub will not allow the external route. So we cannot make the communications. So what is the solution? So the solution is we can use the special area that is known as the NSSA area. So NSSA area is going to be there, and this NSSA area is going to allow the LSA. That is going to be LSA1, LSA2, LSA3, and LSA7. This is normal NSSA area. But if you're going to use the totally NSSA area, that will again replace the LSA3 as a default route. Rest is going to be still there. Same concept. So let me make as a normal NSS area. So simply I'll go here and I will change the configuration. Show run section OSPF. And I'll go here, configuration terminal. And I will just remove this first two command. Okay, so might be it is not going to remove everything. Always verify. Whenever remove this command, no, always verify. Might be it is going to remove your this keyword. See, still the area 0 is going to be there. Sorry, area 11 stub is going to be there. So I need to again use this command to remove this full syntax. Now you can check. So need a 2 time to remove your complete stub configuration. You have the 2 syntax. So I'll run the command as a OSPF. Okay. Now I'll go up here, router OSPF 10, and I will use the area 11 as a NSS area. Okay. NSS area, and later we'll make as a no summary as a totally NSS area. So now it's done. See, your neighborship is going down because your area type is mismatched. So I will configure here as a show run section OSPF. Configuration terminal, I'll go from here. It's very important. See how I am removing. If I'm running this, no, it's not removing all the command. Okay, I need to again remove this command by using the okay. Show run section OSPF. If we run that, now I'll go again and use the area 11 and NSSA. Clear? Now you'll see that. The moment I will do that, your neighborship is come online. You can see neighborship is come online. And most important, if you just check the show IP route, in that case, I should start getting the external route. Let me show you. That is a very important. Earlier it was not coming. But what is the metric? You can see the new metric. Anyone able to recognize?
Yeah,
N2.
Flag. See, N2. So by default, if you any metric getting like E1 and E2, E1 and E2 is external route. There is another metric N1 and N2. You can see this is also a flag that is going to be external route. So similar, like you can see for the E2, we have the default metric as a 20. At the same concept is going to here. By default, if you're not changing the metric type 1, in the NSSA domain, any route is coming, that is going to consider as a metric as a N2 flag. So by default, the cost is going to be 20. So N2 is basically it's a NSSA route, but it's external route. Any external route is going to come across your OSPF domain. If it is coming as a external domain, it's going to be N2. But as I mentioned, when this route is going to be translate back to the any other area via the AVR, N2 is going to translate it as a E2. So I have seen this kind of questions are going to be asked in the interview. Interviewer draw the similar topology and say, okay, we have the EIGRP coming as a one external route in the NSSA. She's going to see the flag as a N2. But what if this route is going to be there? It's going to be N2 or some other flags. Most people say, no, it's going to be N2 only, but not like a true. LSA 7 coming as external via NSSA. Let me put it here. Via NSSA, that flag default N2, but when it is going to be move in the different area, this LSA 7 is going to translate as a LSA 5, and LSA 5 only have the two type of the flag, E1 or E2. So if this is the N2, by default, it is going to flag translated as a E2 route. If it is a N1, the flag is going to be by default translated as a E1 here. So whenever the route is going to be translated from one area to another area, the flag also going to be translated. Make sense? So you can see in this database, if you check in the R4 point of view, the route is receiving, that is going to come as a LSA 7. Let me show you. But if it going in the, let me show in the first this particular router, you can see this router have the LSA1, LSA2, LSA3, and LSA5. This subnet 666 is coming as a LSA5. Clear? Because it's a E2 route. LSA7 is only going to stay in the NSSA. But in the R4, if you check that in the R4 router, show IP OSPF database, you're going to find it here. Check in the area 11. See, we have the external LSA. That is from the LSA7, and this the LSA5. Why it's LSA5 is getting here? Because this need to be sent in the area 0 as well. But if you check for the R5 now, you are going to get only the LSA7, no LSA5. So show IP OSPF database. So 1, 2, 3, and 7. Clear? So NSSA is going to get LSA 1, 2, 3, and 7. Any doubt anyone have? And this is story. N1 route, N2 route, E1 route, E2 route, and the area type till NSSA. Okay, so now the last use case, we have to talk about the totally NSSA. Totally NSSA again going to carry LSA1, 2, and default route under the LSA3. Very important. I'm emphasizing, make a note. And then LSA7. So how I can make that? So take this output as a reference, and I will just make that changes here. Configuration terminal, I'll go with router OSPF 10, and I'll just, I'll just use a keyword as a no summary. No summary, done. And if I go there in the show run section OSPF, and I'll just use this as a no summary. Now I'll just clear IP OSPF process. Sorry. Let me do here, clear IP OSPF. Okay. Now you can check it here. So we can check show IP OSPF database. First, let me show you. Let me first check the neighborship is up and working. Now see, LSA1 is there, 2 is there, and 7 is there. But in LSA3, we only have default route. Show IP route, you can check. Only have default route in LSA3. Earlier, we have the full routing information. See, everything was there. But LSA3 is going to suppress as a default route. So LSA3 is going to be there, but only default route. And here also you're going to check that show IP OSPF database. You're going to get check in the area 11. You're going to get this all information, and here is going to be your LSA7 as in LSA7 is there, and LSA3 having only default route. So this is the spatial area type: stub area, totally stub area, no service stub area, and the backbone area, normal area. Any questions, any doubt till here? Anyone have? Okay. Now let me make as a normal area all the things. Okay. If there is no question, I can just make as a normal area. Means I will just already conclude these all things. So let me make as a normal. So I need to run this command 2 times. First is this one, and second one, this one. Okay. So it's become a very normal area. And I'll go there as well. I'll go and say, so section OSPF. Okay. So now it's become a normal. So we should have the all end-to-end routing informations. If you check it here, show IP route. Let me check. Yeah, it's still not getting all route. Yeah, now we start getting the all route. Here is good. And here also, if you check it, it is going to be good. All right. So let me talk about. Let me stop this record. Let me talk about something very important. Let's suppose in OSPF, let me see what we'll all cover. So we cover this area type, backbone, normal, NSSA, total list of area. We cover about the internal backbone router, AVR, ASBR. We left with the virtual link I will discuss about. So I'm going something, a new topic, which is not part of this, particular discussion. That is the default route originations. So let's suppose there is a requirement to originate a default route in the OSPF domain. There is a requirement. Somebody is going to ask you, that is out of the box, CCA label discussion I'm doing right now. Somebody asks you to inject the default route in the OSPF domain. Then how you are going to do that? If you want to inject the default route, then how you can do that? So there is two methods. Sakil, might be you know that, but other might be not aware about that. Yeah.
Yeah.
So,
either it should be in a routing table, or we have to enforce it.
yes. So if I'm in the ABR, yes. So if I'm in the ABR, let's suppose I'm in the ABR, you can see there is no default route, right? So if any area you want to default one of the default routes, so there is a two prerequisite. There is two command is going to be there. The one is going to be default information originate. Another command is going to be default information originate always. Okay. So we have to understand what is the behavior of these two commands to inject the default route in the OSPF. So if you're using the default information originate, this I is missing here, ignore it. So what is going to happen if you have already default routing the routing table, then it is going to be redistribute in the, means it is going to be originate the default route. If there is no default route and you want to still inject the default route from any router or ABR, you can just use the default information originate. So by default, this particular router will originate a default route for any connectivity point of view. Let's suppose in this situation, I don't have any default route. Okay. But I want to inject a default route in the area 0 or area 11. Any can I can just choose that. So I can just simply go here and go in the show run section OSPF. And I go in the configuration. I can use the router OSPF 10. And I use the command default information originate. And I can use the always keyword. The moment I will just press, I'm not defining the any area or all. So it is going to be originate one of the default route, and let's see that. If I go here now and check show IP route, see you start getting a default route here by default. And if you check in this R5 as well, go in the R5 and check as show IP route. This also start getting a default route. So default information originate, whenever going to run in the AVR or any other router, it will simply generate the default route. if using the always keyword. But if I'm going to use, no, I don't want to use the always keyword. I want to use the default information originate only command. In that case, this default route is will not by default going to be advertised. Let me show you. So if I go here, I'll remove this configuration. Let's do, and let me do the verification again. Show run section OSPF. Yeah, so see, I removed this command, but only the second keyword removed. So it's very important, guys. Route map, prefix list, anything you're working and this kind of redistribution, make sure you keep checking unless and until it is going to remove your all command. So now it's remove all the command. Now I'll go and run the command default information originate. And I will run, then you will see these are not getting any route here. No default route. Even go for the R5 also, you are not going to get any default route. So how I can put the default route? So if you're using this default originated route, so you must have to make you have to meet one condition. This router should have one of the default route in their routing table, either valid or might be dummy. Then only it is going to be originate. So I can put any default route, random default route, just for showcase. So you can just go here. I'm just going to put one of dummy default route. So I'll put as a IP route 000000000. Null 0 is basically dummy route. I'm originating a one default route to going to be reach every my OSPF neighbors in different area. And if anyone want to get the default route, they come to me, and then further I will decide how to send the traffic. The moment I add this dummy route, null 0 is basically there is no valid destination, but you come to me, and after that I will tell the path where you have to go that. So technically it's a dummy route. So if I go here and check now again, you'll see you will get the one of the default route. So default information originate is only inject the default route if we have a default route in your routing table. Default information originate will going to inject the default route if you have a default route or even you not have a default route. In both cases, it is going to generate the default route. Clear? Okay. Now, last thing for today, we have to do the path manipulations. Let's suppose we are getting the bandwidth, like we have to discuss about that path preference. Right now, you're getting the route. If I'm going the R1, you can check. If any prefix coming from the any destination route, let's suppose you getting this route, you have a two path. Why they're getting a two path? Because they have both path have the same metric, and metric is cost. So if you want to manipulate the metric, so how you can manipulate the metric? You can manipulate the metric by manipulating the cost. So basically, to manipulate the cost, there is two methods. We can use the link bandwidth, which is going to be lower side, then it is going to be cost is going to be higher, or we can just do that cost change as per the OSPF configuration, right? So I will just do that. Link bandwidth you want to see, guys, or you can do by yourself. I can just make the link bandwidth is lower. It is going to be if you want to change the link bandwidth, so you have to give the bandwidth like 100 Mbps or 10 Mbps. Let me make the one as a link bandwidth. So I'll go here and make this link bandwidth as a 10. So let me go on my let me go and make as a R3 and the R4 router interfaces. So I'll go here. So first I will show in the bandwidth, how based on the bandwidth you're going to be interface is going to be gig 0/3, and bandwidth I'll make it a 10 Mbps, 10,000. It's going to be 10 Mbps. And I will go for the R4 gig 0/3 as well. Configuration team gig 0/3. By default, it's a 1 GPS. So they have the same cost. 10 is going to be OSPF cost calculation table based on interface bandwidth. So as we discussed earlier, right, we have the slower link which have the higher bandwidth. So Ethernet, why I'm making it 10? 10 is basically having a cost 10. But if anything more than the 10 Mbps, means if your link is a fast Ethernet, cost is going to be 1. Gigabit cost is again going to be 1. So I'm making this link as a Ethernet as a 10 Mbps. So this is going to be also bandwidth is 10,000,000. Done. And also I'll make this done. So now if I check, I'll check clear IP OSPF process. Okay, now you'll check it here. See. Okay, let me clear the OSPF again. Clear IP OSPF process. This must be going to change the metric calculation again. Show IP route. It's not calculating the bandwidth. Why? Still showing the same bandwidth. Gig 0/3. Let me check. Show run interface gig 0/3. Where I make the changes? 3 and 4. Gig 0/3. Oh, I make this changes on this particular router. But why I make this changes on this router? Let me correct this. Configuration. I need to change in the router 2 now. No bandwidth 1000. Let me make it the correct thing. Okay, this is fine. R4, I need to go on my, let me check the R4 as well. Sorry, guys. So R4 is fine. Interface gig 0/3. Okay. 10 Mbps. It's correct. 10 Mbps is correct. No, it's a 1 Mbps basically. It's become not 10 Mbps. So should be bandwidth 10,000,000. Okay. Gig 0/1. So show interface gig 0/1. So I want to just see, this is my 1000 Mbps. 1000 Mbps have the 30. 10 Mbps also should have the 30. So we are good with the layer. 10 Mbps is equal to 30. Now I'll go in this particular R2 as well. Configure the interface. I'll go here. And bandwidth is going to be 10,000,000. Clear IP OSPF process. Let's wait for a while, guys. We'll see that. I want to show for the interface. I'm not sure it's going to support or not, but should support when I'm minimizing the bandwidth. If not, I will do the manual way for the cost manipulations. Show IP route. No, it's not. Okay, let me do one thing. Let me do one thing. Let me change the metric type from here to the route. I want to change one end-to-end metric. So do show run section OSPF. I want to use the metric type 1. Okay, now let me check it. In the R2 point of view, should the E1 metric? Yeah. So it's not taking that metric which I'm making as a 10 Mbps. How to change OSPF cost for link 1 Gbps to 10 Mbps. The same command I need to change the. This is the one thing I was going to tell, but bandwidth also should go, right? There is the auto reference bandwidth. We can give that for the higher lower link in that case. So I believe this will not work. The global way is not. I was just trying to change the link bandwidth, so it is not calculating. It's still taking as a 1. So there is another method we can do that changes for the cost manipulation. That is the OSPF cost. I can just go on the interface and I can give the explicit cost value for the per link. So I will check this one. No worry. It is going to valid. If not going to valid, I can use the specific link. I need to use the link like Ethernet or serial link I can use, and I can just show you. Ethernet link might be I need to use that, which have the by default 10 Mbps bandwidth. But I'm trying to lower down the bandwidth. It is not taking for some reason. Let me try one more. So take that as per logic. Give 0/3 and let me check. See, this bandwidth is showing 10 Mbps only, but still not taking the calculations. Here IP OSPF process. Let me try one more time. Should take, right? Clear IP OSPF process. I'm not sure why it's not taking, but should take. No, it's not taken. Okay, let's move in the different directions. So I will just skip the same bandwidth. Let's wait for one more time. Still okay. Yeah, not taking. Okay. So let me go and reverse the configuration. Okay, I will just go and gig 0/3. I will simply go here and no bandwidth and IP OSPF cost. You can give the cost on the interface base. So if you give the higher cost, it is going to be not preferred. So you can see more higher cost, it is going to be not preferred. So I'll give the cost as a, let's suppose 50 for this link. Okay, and I'll go for this one also. Show run interface gig 0/3. And I'm going there. I can just remove this bandwidth. No needed for this one. And IP OSPF cost 50 and then clear IP OSPF process. I can do this one and I can just clear IP OSPF process. Done. Now we'll see that it should change the now behavior. So now if I'm going and check the show IP route, let's check the route. Very strange. It's not changing the cost. Show IP route. No, it's not changing the cost. Should change the cost, but Let me think. So we are doing the cost for this link higher. Let me make the cost for this link also higher. Let me do that. Give me 1 second, guys. Show run interface gig 0 by 0. IP OSPF cost 50, not 550. Done. And this is also, I'll go here and show an interface gig 0 by 0. Config T interface. Sorry, interface. IP OSPF cost 50. Now let me shut down this neighbor. I just want to verify the cost part. Let me shut down this neighbor. I want to just check one link. Clear IP OSPF process. Show IP route. Yep. So you guys see here, the cost has been increased now. So you are getting the cost is a higher. Earlier it was just, normal cost, but now it's become the higher cost. So even I'm just changing the cost for this one, it should be increased, but let me again turn on this link. So definitely we have the cost, higher cost. Now earlier it was a lower cost, but now we have started getting the higher cost because of the cost of the link I have changed. But let me turn on again this router and let me see that what is happening. So you can see now we have the best route, which is having the lower cost. Give me 1 second. Okay, so you can see now this link is getting preferred. Why we have the lower cost? This link is not getting preferred because they have the higher cost. You can see this link having the higher cost. So basically cost is basically going to be calculated per link. You can just want to make any path, but this cost is even going to be, if I'm making the any segment link cost lower, it is going to work. I don't know, I need to rephrase the topology or something else. It should work, 100% going to work. And even if I'm going to use the any link which is going to be slower link, that cost is also going to work. That is the definition. If you're going to make the actual bandwidth on the interface, then definitely your cost is going to be higher. Okay, so this is how you can do the like calculations and give the access to the, for the any kind of the OSPF router distributions and the managing the path. Any question?
Yes, it's good.
Okay. All right. So we'll continue tomorrow. Tomorrow we'll discuss the virtual link. That is the one topic we left it. And I will take the question if you have any question and all. So we'll discuss that also. I'll make that virtual link calculation configuration from this link to the this area 22, and we'll see if have the any kind of the area which is not directly to the backbone area, but still they want to part of the OSPF domain, then how it is going to happen and how this virtual link is going to be created. So I'll make tomorrow, same time, I will continue from here. We can conclude this. Okay, guys. Thank you. See you again
Yes,
tomorrow.
sir. Thank you.
Thank you.